Students often want to know why mathematics is so important if they are going to become a doctor one day, or a lawyer, or a sports person, for instance. Something where the link between algebra and trigonometry and geometry doesn't quite seem as clear as, for instance, in engineering or architecture or accounting. Now, the answer to that lies in this one and only mathematical process expectation from the curriculum: reasoning and proving. Now let's see what the curriculum says. Students will develop and apply reasoning skills. For instance, recognition of relationships. If you can see a pattern, then you can use that pattern to start forming conjectures, which we'll come to later, about what might happen in the next case. The relationship between variables, the relationship between numbers, all of the relationships in mathematics are of critical importance, and students need to be able to recognize them. Generalization through inductive reasoning, very important. For instance, knowing whether it's going to be right or wrong to say that since the last 5 days we had sunny weather, meaning tomorrow we will have sunny weather as well. Is that a good or a bad argument? The intuitive and the instinctive reaction to good or bad arguments using inductive reasoning and generalization of an argument through inductive reasoning comes from mathematical skills. And the use of counterexamples. Maybe somebody has proven that the last 5 days have been sunny. So you need to show by virtue of counterexamples that the next day, the 6th day, may not necessarily be a sunny day. It might rain for all we know tomorrow. There must be a way of counter-proving or countering the argument using some counter-examples or some good level of reasoning and arguments. And these are all used to make mathematical conjectures, basically the theorems that you know, the laws, the rules that you use. You need to assess the conjectures. In other words, what we've just said, if a statement is made about something being true, you need to be in a position to assess whether that is actually going to be true. You have to have the knowledge and the skills to assess theorems, and also you have to justify your own conclusions. Otherwise somebody else might come along and prove you incorrect. You need to plan and construct organized mathematical arguments. Probably the most important sentence of this whole paragraph. You need to be able to plan and construct organized mathematical arguments, making sure that your argument is watertight in terms of mathematical accuracy and mathematical laws. You're not transgressing any mathematical rules in the process.